What if we could clean up the junk floating around our planet and turn it into something useful right in space? That's the incredible idea behind this research paper on manipulating metal without ever touching it. Welcome to Summarize Science, where we look at the amazing work being done at the cutting edge of technology. The ultimate goal is a four-stage process for recycling space debris. First, you collect the junk, then you melt the conductive metals like aluminum in a furnace. The crucial and difficult third step, which this paper focuses on, is moving that molten metal from the furnace to a casting mold, all without contact. Now, aluminum isn't normally magnetic, so how does this work? The secret is to use rapidly changing or oscillating magnetic fields. These fields create tiny electrical whirlpools inside the aluminum, called eddy currents, which generate their own magnetic field that pushes back, allowing the object to be levitated and controlled. To test this on Earth, the team built this 5-coil electromagnet array. And since they can't just turn off gravity, they simulated it by placing a hollow aluminum sphere in a water bath. By filling it with just enough water to make it almost perfectly buoyant, the tiny remaining effective weight is small enough for their magnetic system to lift and move around. The big breakthrough in this work is the use of a closed-loop control system. Think of it like giving the system eyes and a brain. 3 cameras constantly watch the sphere's position, and a computer controller instantly calculates the exact magnetic forces needed to keep it on a desired path. To prove it works, they programmed the system to move the sphere along a complex 3D path, drawing a small square, moving up, and then drawing another square on top, like building a cube. The results were a huge success. This graph shows the positioning error, and as you can see, all 3 of their new closed-loop strategies were significantly more accurate than the older, pre-programmed open-loop method. But what's really surprising is their finding on energy efficiency. They tested a strategy to use the absolute minimum amount of power at all times, and found it was just as accurate as the less efficient methods. This chart shows the power consumption, and the min-power strategy used an order of magnitude less energy, which is a massive deal for power-limited applications in space. This new smart system is also incredibly robust. Even when the magnets had to make a sudden, jarring change, which you can see here, the controller was able to quickly correct the error and get the sphere back on its path, something the old system couldn't do. So let's quickly recap the important takeaways from this research. The team demonstrated highly accurate, real-time control of a non-magnetic metal object using only magnetic fields. They proved this can be done with extreme energy efficiency without sacrificing performance. And finally, their system is robust enough to recover from disturbances and stay on track. This is a critical step towards making in-space manufacturing and recycling a reality, potentially transforming space junk from a hazard into a valuable resource for future exploration.